Hi, so in this video we're going to be talking about linear regression. Now what is linear regression? Linear regression is a technique where given a set of data points we try to come up with the best fit straight line that relates the input and output parameters. Alright, now let's go ahead and do this step by step. Now the first thing that we need to do is we need to import the necessary libraries or packages. So we import matplotlib.pyplot as plt, then from scipy scientific python import stats. So let's go ahead and put in our values 2, 4, 5, 7, 8, 9, 10, 11, 12, 13, 15, 18. Alright, then the values for the output. Okay, 20, 37, 46, 58, 65, 71, 73, 82, 88, 92, 95, 98. Alright, so let's go ahead and do a scatter plot for this first. So plot.scatter, okay, x, y, and let's give it a title. Okay. Students' performance in EGN 1273. Okay, so we will label the x-axis as the weekly study hours, and plot.y label as the grade or final marks. Okay, and let's have the legend as well. Let's put the label here. Okay, so I need to do plot.show. Alright, so these are the observed values. Alright, let me put the legend here separately. Observed values. Alright, now what we want to do is we want to be able to get a best fit line. Alright, now to draw a straight line, we know the equation is y equals to mx plus c. That is a straight line equation where m is the gradient and c is the y-intercept. Alright, so basically if I want to draw a straight line, I just need these two parameters m and c, and then I can draw a straight line using these two values alone. Okay, so what I need to do, I need to be able to call this linear regression function that is provided in the statistics package and obtain the gradient and the y-intercept. All right, so let's go ahead and do that. Now, when we call the linear regression function, okay, so the function that we call is stats dot linear regress, and we pass in the x and y values. Okay, and we put it up here. All right, so when we call this function, it of course returns to us the two important things, which are the slope, the gradient, and the intercept. All right, but together with these two parameters, it also gives us some performance metrics, okay, to tell us how good this straight line is. All right, and the three sort of performance metrics are the R value, the P value, and standard error. All right, now what are these R values, P values? So this R or R squared values range from 0 to 1. All right, and it tells you how well the data fits into the drawn line. And the P value is also the strength of evidence against the null hypothesis. Okay, basically it means it sort of gives you an indication of how statistically significant, all right, this estimation is. All right, and standard error is again trying to find the average error, okay, across all the data points with this straight line that we have obtained. All right, so what we need to do is, or what this linear regression function does, is it gives us back these three parameters as well. So R, okay, P, and the standard error. Now, in order for me to draw the straight line, I need to have a straight line equation. So I can define a function, my function, where I pass in the x values and I return, all right, the straight line equation. So m x plus c. Okay, so m in this case is the slope, the gradient, x is the values that I pass in, and intercept is the y-intercept. All right, and what I need to do now is to pass in this range of x values, all right, into this function. Okay, and how I can do that is by creating or to generate the y values for these x inputs, I can call the map function. So I list map my function x. So what does this map my function x do for us? It takes in this x input, okay, this x input, and passes it one by one into my function, okay, and it generates a return value. So for every x, I will return a value which is the y value, and I'm creating a list of that. So what is my model? My model is basically, all right, the new y values for this x inputs based on the straight line equation that I've obtained from the linear regression function. All right, that is what this is. So now with once I obtain this, I can actually go ahead and plot. Okay, I can plot the new line. All right, so let me go ahead and do that. So I'm going to plt.plot. All right, I'm going to plot x with my model. All right, and I'm going to say r dash dash. All right, so let's run this. Okay, so now you see this. Okay, so let me explain again. So the dots that you see here are the actual observed values. Okay, these, okay, let me put in the legend over here. Linear regression line. So the red line is the linear regression line. Okay, so what is happening is x and y originally are represented with the scatter plot, the blue dots. All right, and using this linear regression function, I am trying to find the best fit line, all right, that is representative of this scatter plot. And to draw a straight line, mathematically we say y equals to mx plus c. So the two important parameters are m and c. M is the gradient of the slope, c is the intercept, the y-intercept. So these two parameters are given as a result when I call the stats.linear regression function, passing in the original data. So using this slope and intercept, I can now form an expression mx plus c. Okay, that is this. So what I need to do now, for this original x data, I need to generate new y data so I can draw the line. So that is where this code comes in. Okay, so map my function x. What does it do? It takes in this x values, this list of x values, one by one passes it into the my function. So for every x, now I generate a new y, xy coordinate. And this sequence of new y values are now mapped to a list. Alright, so now I have x as the input and the new y values are called my model. So now I am plotting x with my model, which is a straight line. So that is what you get. Alright, now besides this, again, like I said, the r value, p square value and standard error are also written. So I can also print them out. So I can print out my r value, okay, I can print out my r value, I can print out my p value, and I can print out my standard error. Okay, so these are the performance metrics that you can get here. Now, one of the other things about linear regression is once I get a straight line representation, I can now use this straight line to find results for unknown or missing x values or predict, okay, the output for some new x value. Okay, so for example, if I see down here, there is no output for x equals to 6, but now that I have a straight line equation, I can actually get that data. So I can say that if a student studied for 6 hours, what would be the grade? So I just call the function again, which is a straight line equation, and pass in 6. So what is 6? 6 is basically x, because this is mx plus c. So when I pass in 6, I'm able to get result for 6 hours. 6 hours. Alright, so you can see the marks would have been 50.85. Alright, so this allows me to use this linear regression line in prediction. Okay, that means for even if I don't have the actual experimental data, I can use the linear regression line to pass in a new x value and understand or know what would be the output. Alright, so I hope that this example gives you a clear idea how to use linear regression in your code. Alright, thank you for watching, and I'll see you in my next video. Bye.